In our day-to-day lives, we basically put our trust in software. But given what we read about in the media, the question is, how warranted is the trust we place in that software? So we would like to think, and we would hope, that when somebody builds some software, what they're going to do is think about security as early as possible. But there's still an open question about what that entails, because when you design software to do something, you design with some function in mind. You don't really think upfront of security. So we don't really have any examples of what it means to build security into something. So what happens inevitably is that we focus on the design of the technology and we hope that people will work their way around the technology, which sort of defeats the purpose of technology, because technology is designed for people and not the other way around. And from a security point of view, a number of people have even said, well, if we have, for example, a water treatment plant, let's design the software in that plant in such a way that Homer Simpson can use it, which from a security perspective might sound reasonable, but Homer Simpson isn't going to use the software in that plant because Homer Simpson is a cartoon character. And I think it worries me a little bit that we are designing software for cartoon characters rather than actual people. So designing for security is simple in theory but hard in practice. So in theory we have a user who is going to use some software that we're going to design and build. We have a designer that's going to design that software. We have an attacker that is looking to either extract some data or compromise some application in some way which is undesirable to our user. And we have a security engineer who is going to design security mechanisms and in some way is going to stop the attacker from being successful. So that's the theory. In practice, however, the user isn't a user. There is no such thing as a user. Users might be producers, they might be, they're real people. They have names, they have jobs, they have tasks, they may be happy, they may be sad, they may be bored, and all of this has some impact with respect to how someone is going to use some software. The designer could be an analyst, a software developer. There is no model designer, just like there is no model attacker. Attackers have different levels of technical expertise, they have different capabilities, they have different goals, and in a similar mindset, a security engineer may be someone technical. It may be someone that understands some technology, even some security technology, but they may have different understandings of the domain. And inevitably, the model that a security engineer or even a designer or even a user might have about a system is not the same model as an attacker has. And that makes designing security hard. So I think to get a handle on these sorts of problems, we need to look at the tools we use. And this isn't really a new problem. And we've known for over 40 years what some of these problems are. We know that there is no silver bullet, there's no one solution that we can use to design bad things out of software or design security in. We also know that software is complex. It's the most complex man-made artifact in existence. And we can't really reason about software without using some sort of a model, some sort of abstraction to help us make sense of the wood for the trees. So the software that we can use for designing for security and even designing software in general hasn't changed. It's a sort of cobbler's children syndrome, in the sense that we can design software that can actually change the world and do all this fantastic stuff. But the software that we use as designers is actually quite basic. And inevitably, as software becomes more and more complex, the problem of designing becomes harder and harder, particularly given that people's needs aren't becoming any simpler. So what happens then is when we start thinking about security is that the scope for error is actually significant. And all we need to do is get something wrong once, and that leaves a door open that an attacker can exploit. So CAIRIS is our attempt to understand this 40-year-old problem. We wanted to look at what software would look like to support the design for security. And we want to evaluate how effective a tool would be at designing security into software. So CAIRIS is actually a number of things. It's a tool for managing and visualizing data, not just from the perspective of the software design, but also from the perspective of security and usability as well. So from our experience, we found that it's hard to get people excited about designing for security. So CAIRIS is useful by acting as an aid memoir. So as we enter data in, it will give us cues about what we should be entering at what particular points. And it allows us to really help capture data about security without security getting in the way of design. So CAIRIS is also a tool to help you make decisions about your security design. It helps you do this by actually automatically connecting data as you enter it in. So we found that designers don't want to do this stuff manually, but we have some ideas about what data should be connected to what. So by automatically associating this data, we can actually visualize how all the data comes together. So by doing this, we can see the impact that different elements of system might actually have on risk. We can also look at the impact that activities carried out by an attacker might have on software that a user is trying to use. We can also see how changing the context might actually change the risks in a system. So a risk that might be significant in one environment might actually be insignificant in another. CAIRIS has also been designed with extensibility in mind. So it's easy to import data from one tool into CAIRIS and also export data out of CAIRIS into something complementary from another tool to a customized report. We've used CAIRIS to improve the design of security in a number of real-world projects, and in doing so, we found out a few things. So we originally designed CAIRIS to support a participative approach to security design, where we have different participants with different levels of expertise, such as expertise about the system we're building or security, can come together to help understand requirements for the system and risks that might impact it. But these workshops can be pretty tedious. So CAIRIS added value by really giving us not only a means for entering data in real time, but actually providing some real-time analysis and visualizing the inputs that we put in to really stimulate the discussion. For those that prefer to use low-tech tools to either understand user experiences or understand different threat models, CAIRIS allows people to use this technology, which can then be marked up and then imported into CAIRIS. And what this means is you can have lots and lots of different data, and CAIRIS can be left with the job of actually consolidating that into one big consistent model. We've also found that CAIRIS is easy to extend, and what we've done is that we've actually extended the tool to support other stages of software design beyond just understanding risks and understanding requirements. So for example, we've extended CAIRIS to capture information about different software architectures. So we can understand what happens when you embed a software architecture into an existing environment and how exposed part of that architecture might be to potential attacks in that environment. We've also used CAIRIS to understand and model the human and social nuances associated with the environments where the software we're building will end up living. For example, we can model aspects of different people to understand how they might use software in unintended ways. And we can also model the impact that different software designs might actually have in these different contexts of use. CAIRIS is an open source project. It's freely available for people to use and extend as they wish. So by making CAIRIS available to the wider community, what we want to show is that while there still isn't a silver bullet for software design, security doesn't have to get in the way of innovation, and it is possible to design exciting and groundbreaking software which is secure by default.